So what are the operations that on sets that you should be familiar with? We have the union, the intersection, the complement, and subtraction. So let's take an example. I'm gonna take a universal set of that example that we used earlier, all the digits used in the decimal number system. So you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The universal set contains 10 elements. Let's take two other sets. Let's call A as the set of all numbers divisible by 2. So it's going to be 0, 2, 4, 6, 8. B is the numbers which are divisible by 3. So it's going to be 0, 3, 6, 9. What does union stand for? Union stands for the concept of OR. The notation is A union B. So union is an operator that requires two or more operands. Like if I had a third set, I could have said A union B union C as well, but it requires at least two operands. And we'll look at the two operand case here. A union B means elements that are present in A or B, or both. It could be both as well. So then it will be 0, 2, 3, 4, 6, 8, 9, which are basically numbers which are divisible by 2 or by 3. That is union. Then you have intersection, which is logically AND. A intersection B, this is the notation, and we are looking for elements which are present in both of these sets. Not either of the sets, but both of the sets. And if you have let's say more than two operations or operands, you will say elements present in all of the sets involved, elements present in A and B and C. But I'll look at our binary case here. Present in both A and B, that would be 0 and 6. That is intersection AND. Then you have the idea of a complement, which is a unary operator. You just need one operand, which is basically not. So A complement, you can write it either like this or like this, doesn't matter. A complement is basically elements which are not in A. So numbers which are not divisible by 2. So instead of the even numbers, you will have the odd numbers. All the elements which are not in A, the operator works on a single operand. So that will be 1, 3, 5, 7, 9. Then you have subtraction, A minus B, which is basically elements that are present in A but not in B. So you won't take the 0 because it's present in B as well. You will take the 2, you will take the 4, you won't take the 6, also present in B, you will take the 8. So basically from the list of elements in A, strike out the ones which are also present in B. So then you will get A minus B as set 2, 4, 8. One question you will have is, what do you do with the elements that are present in B but not in A? Don't do anything, ignore them. Quite simple as that. So these are the 4 basic operations that you see on sets. Let's quickly look at what this looks like on a Venn diagram or visual representation. I will have two sets for A and B. That's my A and that's my B, and I will draw a universal set. Everything will be inside the universal set. So my set A contains 0, 2, 4, 6, 8. my set B contains 0, 3, 6, 9. Notice that 0 and 6 should be present in both of the sets, so you will write them here. Everything else that was present in A would go here. This is a region. This region right here is inside A and outside B. So that's 2, 4 and 8 will go there, while 3 and 9 will go there. What are the other numbers in the universal set? 1, 5, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is basically what a visual representation of this would look like. My universal set and my A and B inside. There are common elements in A and B, so the circles should intersect. There should be a common area. There will be area which is outside B and inside A. There will be an area which is inside B and outside A. There will be an area which is outside both of them. That's basically what you have in a two-set Venn diagram. You have 4 different areas. Now let's look at these operations quickly one by one. A union B basically means A or B, which is, we have listed it, but visually the area would be all of this. This would be my A union B. My A intersection B would be the area which is both A and B. My A complement would be everything outside A. Ditto for B complement, everything outside B. Then I have my A minus B, which is this portion here. Everything that's in A but not in B. A minus B. And similarly, you can draw B minus A as well. You can also represent them by talking about each region separately. This is okay, let's start with the innermost one. This is A intersection B, and going forward I will not write the intersection. You simply write A, B together. It is understood that it is A intersection B. This region, which we said was A minus B, we can also represent it as A intersection B complement, because it is inside A. It is the common region of A and the complement of B. Inside A and inside B complement, which is the same as inside A and outside B. This portion right here is A complement B, and this portion right here is A complement B complement. Notice that there are 4 regions in a two-set Venn diagram. We'll elaborate on this further.